All right, so here is the first section of notes. So we are into the unit of factors and facts. So we're going to be factoring. We're going to be dealing with some fractions today. So yes, we are going to be dealing with the F word today. So factors, just because I know everyone's favorite is factors. So this is the first thing we're going to go into. The first thing we need to talk about is prime numbers. So prime numbers, when you figure out the factors of it, you just have one and itself. So an example of a prime number here would be, say, the number 5. So I cannot write 5 in as a multiple of two things other than just 5 and 1. So you'd have this, you could have 11, you can have 13, 7 could be in there as well. There's lots of primes. They've discovered prime numbers really big. If you went on Google and looked at that, there'd be a long list. So every single other type of number is called a composite number. So composite meaning you can compose it of multiples of prime numbers. So the first thing I want to show here is how you'd express some things as a list of primes. So if you recall, I know I've taught you this in grade 9, so you should hopefully be able to remember how to do this, is a factor tree. So this could help for some numbers that are a little bit bigger, but for something like 6, this is pretty straightforward. It's just going to be 2 times 3. You'll notice I'm going to do lots of times multiplication as a dot because we're going to deal with lots of x's throughout this year. So get used to doing multiplication as a dot. So that one's pretty straightforward. I'll show you here with 12 what it would look like in a factor tree. So I could factor this into 3 times 4, that would give you 12. And I can factor 4 into 2 times 2. You need to make sure at the end of every of these branches is always a prime number. And then as I write this out here, it'd be 2 to the power of 2, because I've got 2 branches that end with 2, times 3. So this is how you'd write things out as a list of primes. Let's do another one here. I'm not going to do absolutely every example on this. If you want to see that, you can ask me that in class. Let's try 36. So I can break this up into 6 and 6. And each of these, I've actually done that already over here. So 2 and 3, 2 and 3. So we look here, I've got 2 2s, so 2 to the power of 2. I've got 2 3s, so times 3 to the power of 2. And that would be your list of primes, so the product of primes. So with this, yes, you are going to have a calculator. So you can spend some time doing this, calculating with the calculator. However, that might take a little while, and some of these you should be pretty easy to figure out what it is a multiple of. So I want to review a few rules with this. So the rule of 2, whatever number you have a bunch of digits. Whatever the last digit here is, if this one is an even number, you can divide by 2. Simple as that. I think you should know that. Rule for 3. So whatever your digit is, so let's say 123, what you want to do is you want to add each of these digits together. So if I went 1 plus 2 plus 3, this would give me 6. If this number is divisible by 3, then 123 is divisible by 3. So this would be, let's try a different example. Let's do a big one. Let's say 7,211. So if I went through and added these digits, 7 plus 2 is 9, plus 1, 10, plus 1, 11. So the digits add up to 11. That is not divisible by 3. So this is not divisible by 3. I'll get some examples done here. Rule of 5, very easy. You have whatever your number is, this last digit. If this is a 5 or a 0, then it's divisible by 5. And for the rest of these over here, so the 6, 9, and 10, with this, it's pretty straightforward. They're just combinations of the other ones here. So for 6, doesn't meet the rule of 2 and the rule of 3. If it meets both of those, divisible by 6. Rule of 9 is just the same as the rule of 3, since if it's divisible by, so if it's the rule of 3 twice, so if you do that twice, that will work, since this is 9 is just the 3 times 3. So I can do that. Rule of 10, again, if it meets the rule of 2 and the rule of 5. The rule of 9, I'm going to explain this differently because I'm not a huge fan of that way. So rule of 9, basically what you want to do is you do the same as rule of 3, except you figure out if it's divisible by 9 instead. So we can do an example of this. If you had something like 900 and let's say 18. So if you add the digits of this, we've got 9 plus 1 is 10 plus 8 is 18. So since 18 is divisible by 9, this is, you can divide this by 9. So that's the rule of 9. I prefer that one rather than what I had explained before. So ignore that other part, do this part. Okay, so with that in mind, we can actually quite easily go through and do some of these. So let's try a few. Again, I'm not going to do all of them. So 344, it ends with an even number, so it's divisible by 2. If I want to figure out if it's divisible by 3, I add all these digits up. So 3 plus 4 is 7, 7 plus 4 is 11. So no, it's not divisible by 3. And the last digit is a 4, so it's not divisible by 5. And you'll notice we can do this with larger numbers, and it can be pretty straightforward. So last number's even, divisible by 2. Last number's not 0 or 5, not divisible by 5. Add these together, so 2 plus 7 is 9, 10, 12. Is 12 divisible by 3? Yes, it sure is. So therefore, it is also divisible by 3. So you can be able to do that pretty quickly once you get some practice with that. Let's move on to the next page. So a reminder with this, as you're going through these videos at home, you should be noting anything that is confusing. So as you're writing the notes down with me, feel free to pause it, rewatch something if you need to, but also feel free to write down the time in the video where you had a confusing part, or put a star by the number here that's confusing. That way when you come to class, it'll be easy to find what questions you have. So just be aware of that. Make sure that you're asking any questions that you need to once we get into class. Okay, so we're going to try some bigger numbers here, and we want to do this as a product of primes. So like we did at the beginning, but some bigger numbers. So this is especially where making a factor tree helps, because you won't be able to just do all this by hand anyways. Or you can do it in a calculator, but it just can be easier doing it like this. So something like 75, first thing I note, this is 25 and 3. The 25s, you should be able to do that pretty quick. And then 25, you can break up into 5 and 5. So the product is going to be 3 times 5 squared. So you do not have to do this in a factor tree. I am not going to deduct marks if you do not do a factor tree. But if you're stuck, this is just something that's pretty straightforward to do. Let's try 140 here. So because there's a 0 at the end, I know I can divide this by 10. The other one's 14. And then we got 2 times 5, got 2 times 7. So 2 2s gives me 2 squared times 5 times 7. Conventionally, you always put the lower number first. So you start with the lowest number and get higher and higher. That's how I've been writing them out. And I would like you to write it out like that as well. You should know the order of numbers, so that shouldn't take too long. That's basic factoring. Let's try fractions. So the first thing with this is we need to know how to convert between a fraction to a decimal, and eventually we're going to do the reverse as well. But going from fraction to a decimal is convenient because suppose I want to know 4 over 5 or 7 over 16. Which one of these is bigger if you're trying to put them in the right order? So fractions are great. You don't see this really long decimal. However, it's hard to compare. So what I want to do is turn these into decimals. Now, there is a way to do it without a calculator. I've shown you how to do this. However, we're in an age of calculators, so all I want you to do with this is just use a calculator. If you do not know how to turn a fraction into a decimal on your calculator, you need help, come and ask me, but you should be able to do that. So I'm not even going to touch this section. You should be able to go through and just use your calculator. Straightforward. What I do want to get into is factoring a fraction like this. There are a couple ways that you can do this. I'll show you both. So basically what you want to do is get rid of any greatest common factor. So if I'm looking at this, 14 and 5, what I can see is both numbers end in an even number. So therefore I could just divide the top by 2, divide the bottom by 2. And what this would get me would be 7 over 25. And I look and see, is that in lowest terms? Yes, it is. So that would be that. That's one of the ways you can do it. The other way you could do it is you could write these out as their list of prime factors. So I could write this out as 2 times 2 times 3 times 3 divided by 3 times 3 times 5. Again, if you struggle with this, check the previous page. Once I get to this point, I need two factors. So cross out like terms. So I've got a 3 and a 3, can cancel those. I've got a 3 and a 3, can cancel those. And I'm left with 4 over 5. So you can do this. Either method is fine for me. I'm not going to restrict you in whichever one you want. But that's your strategy, is you need to factor out the biggest number that you possibly can from the top and the bottom to get that. All right, so that is the first lesson. That is it for that. Again, if you need to, you can rewatch this video. I'm not expecting you to understand 100% of everything I just said, but you need to at least get the beginning stuff of it. Like I said, if something like this made sense, or you're like, oh, I understand this method, but this is confusing, just go ahead, put a little star by that question, so when you come to class, you can come and ask this question. All right, so I will see you in class, and I'll go through questions on this, and then you'll notice you'll go onto the next page here, where it says practice up at the top, and that's going to be what you're going to work on during class once you've done your questions. All right, so that is it. I will see you in class.